What happens when extreme space objects collide? The moment of impact. Space is not quiet. Not really. It hums. It crackles. It vibrates with violence. And sometimes in the cold dark, it collides, not gently, not slowly, but in bursts of energy so powerful they warp spacetime itself. Black holes, neutron stars, white dwarfs. These are the deadliest, densest objects we know, and when they meet reality bends, this video isn't just about explosions. It's about the laws of physics pushed to their limits. So what happens when the universe crashes into itself? Let's begin. The densest things in existence. First, meet the players. White dwarf stellar corpses, Earth-sized but with the mass of a sun. They're the end state of average stars like ours. Dense, stable, until they're not. Neutron stars even smaller, even heavier. Just 20 kilometers wide, but with more mass than our sun. 1 teaspoon of neutron star matter would weigh billions of tons. They spin, they pulse, they glitch. Black holes, the point of no return. Pure gravity. No surface. No bottom. Some are born from stars. Some sit at the centers of galaxies. All of them are violent by nature. But when they collide, the real story begins. White dwarf plus white dwarf, the silent supernova. 2 white dwarfs locked in a binary orbit will spiral closer over millions of years. Eventually, they merge. If their combined mass exceeds the Chandrasekhar limit about 1.4 times the mass of the Sun, something terrifying happens. They explode. Type Ia supernova, one of the brightest events in the universe. It leaves nothing behind. No neutron star. No black hole. Just pure light and expanding gas. Astronomers love these collisions. They use Type Ia supernova as standard candles to measure distance. But for the stars involved, it's oblivion. Neutron star plus neutron star, the gold forge. When 2 neutron stars collide, the universe changes. First, they spiral toward each other, warping space as they go. The dance speeds up. Time distorts. Then impact. The collision produces gravitational waves, literal ripples in the fabric of spacetime, which we can now detect thanks to LIGO and Virgo. But that's not all. These mergers create kilonovae, explosive events that forge heavy elements like gold, platinum, and uranium. That ring you wear, that satellite part, it may have been born in one of these collisions. What's left behind? Sometimes a more massive neutron star. Sometimes a black hole. Always a scar in the cosmos. Neutron star plus black hole, the silent devouring. This is not a fair fight. A neutron star approaches a black hole. It spirals in. It begins to stretch, torn by gravity. Then it vanishes. No light, No explosion. Just gravitational waves and absence. The neutron star is swallowed whole. Depending on the size, it may be ripped apart, first sending out a flash of gamma rays. But usually, it simply disappears. These collisions are rare, hard to detect. But when we find them, they confirm Einstein, challenge models, and remind us of the universe's appetite. Black hole plus black hole when gravity meets itself. Two black holes don't collide like billiard balls. They merge like ghosts, like gravity consuming gravity. No light escapes, but the collision sends out a shockwave of spacetime, a gravitational roar. In 2015, we heard it for the first time. LIGO detected the merger of two black holes 1.3 billion light-years away. Since then, we've heard dozens more. Each one a cosmic drumbeat, the result? A bigger black hole, a loss of mass turned into energy, and a permanent dent in the universe's memory. The unseen violence of space. All these collisions happen far away. They don't touch us, but they shape us. The gold in your blood, the atoms in your bones, the iron in your blood. They were made in fire infusion, in collision, in collapse. The universe isn't calm. It's catastrophic, and in that chaos, life formed. We are the ash of cosmic accidents. Collisions we haven't seen yet. There are collisions we know must happen, but we've never seen them. White dwarf plus neutron star could lead to a rare type of gamma-ray burst, neutron star plus black hole, plus another black hole, a triple merger. Mathematically predicted, never observed. Black hole with a rogue planet. No one knows what it would look like. And then, there are things we haven't even imagined. What happens when two intermediate mass black holes merge? What happens if a black hole eats a quark star, assuming they exist? We don't know. But Webb might see it, or LISA, or something that hasn't even launched yet. The sound of collision. Gravitational waves aren't just abstract ripples. They can be turned into sound when two black holes merge. They emit a chirp, a rising frequency as the orbit tightens, then a sudden cut-off. It's the most massive sound in existence. A death song. And we're just now learning how to listen. The biggest collision still to come. In 4 billion years, the Milky Way will collide with Andromeda to galaxies. Hundreds of billions of stars, massive central black holes. It won't be a fiery crash. Space is too empty, but the black holes will find each other and eventually merge. A final exhale of gravitational energy. Earth might be gone by then, but the echo will ripple across the universe. A reminder that nothing stays still. Collision is creation. We tend to fear collisions, but in space, they're not just endings. They're beginnings. Every crash reshapes the cosmos, builds heavier elements, sparks new stars, seeds planets, forges possibility. You are made of remnants, of things that hit too hard to survive. That's not destruction. That's birth.